All right, another thing that I wanted to go over with you guys is these two special right triangles that we're going to need to know. But I'm not going to just tell you what they are exactly. I'm going to actually kind of show what we call a proof. Don't worry, it's not like the other proofs that you have done where you've got to do like this works because of this. This is more of an algebraic visual proof. So I'm going to start with this square. Okay, we're going to just say that each side is worth 1 unit. Okay, so all four sides, they're 1 unit long. What I want to do is I'm going to, let's see if I can do this pretty nicely. Nope, not really. Divide this. There's this nice diagonal. I'm going to try and draw one more time. I don't have a steady hand on here, which is okay. Now, it's a 90-degree angle being cut in half. I'm sure you can guess that angle measure. Okay, this is now 45 degrees. Okay, but my real question, like the real question, what is the measure of the hypotenuse? So that's what we're going to find out. We're going to find question mark. Now, remember Pythagorean theorem, we've got two sides, we need a third. So here we go. We're going to do this down here. 1 squared plus 1 squared will give us c squared. All right. 1 squared is 1. That's kind of like, let me use a better color here. So we've got 1 plus 1 equals c squared, which we already know what this is. This is 1 plus 1 is 2, so 2 equals c squared. Now to get rid of the exponent, like in previous units, we're going to take the square root. So c, our hypotenuse length, is the square root of 2. That's this guy right here. So this is the first of our special right triangles. Okay, the angle measures of this one, so we're going to just summarize. The angles are 45, 45, 90 degrees. Okay, now if you add all of that up, it should give you 180 because every triangle should have 180 degrees on the inside. And then for the sides, we have 1, 1, and square root of 2 for the sides. Okay, so that's one triangle. All right, this is one of our special triangles. Now I'm going to put this into a more general form in just a moment here, but right now, 45, 45, 90 with sides of 1, 1, and square root of 2. Okay, we're going to do something very, very similar to our other triangle over here. The only difference is that instead of them being 1, all the sides are 2. Okay, so kind of like with the square where I divided it in half, but I did a diagonal. This one I'm going to cut in half as well, but I'm going to cut it right down the middle. Well, that almost worked a little bit better. Making these little sides now parallel. Now, originally this was 2 units long. Now, each little piece is 1 unit long. I'm sure you can already guess. I'm about to ask, what is the length of that side? Well, similarly with our other diagram, our square, where we found the hypotenuse length, we can find that side length using the Pythagorean theorem. Now, because this is not the hypotenuse that we're looking for, we have a hypotenuse value. We got to make sure that value goes in for C. Okay, this is C. This guy can go in either A or B. It does not matter. So let's just do 1 squared plus, we'll call it B squared. We don't actually know what that value is. equals 2 squared. Okay, we already know what 1 squared is. We just saw that in the last verify. We still don't know what b squared is. And 2 times 2, that's 4. Okay, we definitely have seen stuff like this before. This should not take very long for us to do. Bring that 1 over. So there we got b squared equals 3. Okay, just like last time, gotta get rid of the exponent. We'll take the square root. So b equals square root of 3. Now you notice I'm leaving these as radicals, c and b. C on the 45, 45, 90, and b for our triangle here. All right, b is square root of 3. Now something else I wanted to point out that I failed to do so at the very beginning. The triangle that we've been working with here, this is an equilateral triangle. So all the angles are congruent. Which means that this angle measure right here, because it's an equilateral, is 60 degrees. Okay? Which means this angle right up here, this has got to be 30. And even though this line's not super straight, it does create a right angle. So we get our second special triangle, which is a 30, 60, 90. Now, when we do this particular triangle, you're going to want to do 60, 30, 90. We tend to go in numerical order. Okay? So the angles are 30, 60, 90. And the sides of this particular triangle, I'm going to go, once again, corresponding order. So 30 degrees is opposite the side that's 1. 60 is opposite the one that's square root of 3. And then my 90 is across from the hypotenuse. Okay, I know this looks like a lot of mumbo jumbo. You're probably like, okay, what on earth was the point of this? Well, mainly as an intro to what the actual special right triangles are. Let's take a look at those actual special right triangles. Let's see if I can do this really nicely. Not bad. Okay, so I accidentally switched the order, but it's going to be just fine either way. Alrighty. Just trying to fit everything in here really, really nicely. So this is for our, this one's going to be our 30, 60 triangle. This one's going to be our 45, 45, 90. Now you can put these in different, in the other box, you can swap them. This is just the way how I drew them. So they're going to stay like this. I'm going to start with the 45, 45, 90. Okay. Where n is any value, we can generalize what we just did on the last page. If we forgot, let's move back to the last page. Okay. Remember how we had 1, 1, then square root of 2? Similar idea when we're putting it into a general form. The sides are going to be n, so they don't have to necessarily be 1. They could be 2, they could be 7, they could be a trillion, and this would still work. Hypotenuse is going to be n square root 2. Now, even if we plug like a 5 in for n, it will hold true. It will make a true statement. You can verify that. Number 8 actually verifies that perfectly. It does work. Fun fact of the day. On the 30, 60, 90, the 30, the side across from 30 degrees, is your shortest side. Okay? The hypotenuse is always going to be your longest side because it's opposite the biggest angle measure. So 2n. The side across from 60 is somewhere between n and 2n. It's going to be n times that square root of 3. So once again, tying it back to what we just barely did. Okay, seeing these in general form is not the most helpful. So what I'm going to do is I'm going to walk through a problem where I have to use those special rights. In fact, let's go ahead and do number 8. Find sine of 45 degrees of a right triangle where B is 5. Okay. Let's first set up this lovely right triangle. I'm going to mix it up. Not the perfect 45, 45, 90, but we're going to make this work. We'll say this is 45 degrees right there. So that angle is where we're going off of. So A, B, C. We know that this side right over here is 5. We don't know this one, and we don't know this one. Okay, step 1. We got to find x and y. Okay, so how I'm planning on doing this, I'm actually going to set it up so that I have my general form right next to the actual values on this triangle. So 5, n goes there, x, n goes there, and y is going to have n squared of 2. That actually becomes very, very helpful, because if I know one side is 5, the other side must also be 5. The two legs, I should say. Not sides, I'm going to call them legs. If one leg is 5, the other leg must be 5. So I can then say, well, x equals 5. Y is that value of the leg times the square root of 2. So y is going to be 5 square root of 2. So let me erase my x and y here and put in those values. Yay! So now I can find the sine of 45 degrees. Now, in order to help me out, just as a recap, this is going to be my opposite, this is going to be my adjacent, and of course this is the hypotenuse. Okay, so sine, recap. Let me pick this color actually. So sine is going to be opposite over hypotenuse, which in this case, my opposite is 5. My hypotenuse is 5 over the square root of 2. Now, 5 and 5, those values can cancel out. So we end up with 1 over the square root of 2, and we're going to go ahead and leave it like that. Okay, what I would like you to do before you move on to other notes, fill in a couple of these other problems that are below all of this. So 9, 10, 11, 12. Do a couple of those before you move on to the next section of notes. That way you can see if you feel really confident. The way how I approach this problem is probably one of the nicer ways. There are other ways. I do want to emphasize this. There are other ways how you can approach these problems. They might be more complicated than what I just showed you. But if you prefer that way, stick to it. And we're done with 10.1. See you guys when we do 10.2. Woo! 10.2 is a lot of fun, guys.